everyone. Welcome to our monthly virtual lecture. As a reminder, this lecture is being recorded and is going to be available in our YouTube channel in the coming days. My name is Carla Gonzalez, and I'm pleased to introduce our speaker today, Chris Davis. He will be showing how to run depth-to-basement inversions using VPmg's geometry and homogeneous geological unit inversion in Geoscience ANALYST Pro Geophysics. Whew. This will include a preview of new tools coming up on our next version, 3.3. If you have any questions during the presentation, feel free to type them into the Q&A or raise your hand. Please be aware that Chris may wait till the end to answer the question. All right, go for it, Chris.
Thanks, Carla. So yeah, today I'm going to talk about VP inversions, specifically geometry, homogeneous, and a combination of both to deal with depth-to-basement style of inversion. So today I'm going to start by just the data. And here I have a grid of data that looks like this. Because I told Carla I was only going to be about 10 minutes, I went ahead and downsampled it a bit. But the original grid was 3.8 million cells, and I could definitely do everything I'm showing today on that. It just would take a little bit longer than 10 minutes. So this model comes with just the data as the data observed. And so what we need to do is we need to create a couple surfaces to create a VP mesh and start with that. So the data itself is on a grid here at 0 elevation. So what I want to do is I want to create two surfaces. I'm going to create one at -1 and call that the top of the model, just so there's a little bit of difference. And then I'm going to create another one at the initial model of our elevation. So let me just go ahead and create a DEM surface everywhere at -1. And so what I'm going to do is first I'm going to create a property at -1, and I'll just create the surface from the data at the DEM, and I'll go ahead and call it DEM. So there's the surface. As you can see, it's at -1. Open this guy out just so I can see a bit better. And then the next thing I need to do is create a second surface. I'm going to create it at -6,500 meters. This entire thing is pretty large. So we're dealing with basically tens and hundreds of kilometers here, as it's 387. So to create a second DEM, I'm actually just going to hit Control-C, Control-V, copy and paste. And I'm going to call this my initial basement. And right now it's at the same height, -1. So I'm just going to translate. I'm going to translate it and go from -1 to -6,500. Now, if I look at my two surfaces, I have these things nice and neat from -1 to -6,500. The next thing I need is an actual VP mesh to be able to do any forward modeling or inversion on it. So I'll go to Utilities and bring up the designer. So for this guy, I just want to design my mesh around this data. So I'm just going to select the data, and it's going to select the VP mesh for me, including any rotations that need to happen. I'll tell it my DEM is the top, and I have an initial basement surface. And now I've created a model. So this is what the model looks like. Let me just hide this a little bit. And the model has a unit and a mapped property right here. So I have my initial basement, and that's the pink. This can also be called overburden, because it goes from the surface down to the top of my basement, and my VP basement, I'm just going to name basement. And property can be conductivity, susceptibility, density contrast. So I'm going to just work with density contrast today. And if I wanted to populate values, I would say, okay, maybe my contrast is 0 for my overburden, and I have a 0.2 contrast. And this little f of x is just the mapped property. So now I have the actual map property in 3D. So now I have data and a model, and I'm kind of ready to start inverting. So when I'm thinking about the depth of basement, everyone does it slightly different. So I'm just going to show you the tools to be able to do it. I'm actually going to start with more the longer wavelength features to get an idea of what's going on. So first, what I'm going to do is I'm going to take my model, my data, excuse me, and I'm going to low pass filter about 100,000 meters. And so this is my low pass filtered data, and that's the original. And then I'm going to go to geophysics, and under VPmg, I have quite a few options. I'm actually going to do a geometry inversion. So what I really want to do is take this model here, and let me just turn on the ISO values of the basement. And I want to change this basement height. So first, I need my gravity data set, which is the grid here. And instead of the GZ, I'm going to start with the low pass filtered and give it an uncertainty level. I have a model that's density contrast. And then this is the enclosing half space. So each inversion style kind of has its own what to do with the world. For VP, you can imagine that the enclosing half space is everything around it. And we are going to cut a hole into the earth and insert our VP model. And so the enclosing half space is the half space that's around. So I'm going to give it a value of my basement, since I have a 0 contrast for the top. And I'll start it at the top of my basement as well. And then it says what inversions, what do I want to do? So I'm going to just do a couple. I don't want to really ramp it up here, and I'll go about 10%. And let's just call this geometry. And so now I have a nice geometry just based on the wavelengths, the longer wavelengths of the data. So now what we're going to do is now we want to start to kind of become a little more nuanced with this data set. And so to be able to do that, we want to do some lateral heterogeneities, but we also may want to simply allow it to continue on. And that's going to be this depth to basement inversion. So instead, I'm going to do the GZ instead of the low pass. I'll come to the model, select that, select my density contrast. We have an apply button, so I like to do like 1 or 2 iterations. I really want to make this tiny, and then instead of a percentage in the actual depth, let's just go ahead and say it can't move more than 500 meters per iteration. And this is depth to basement. So what this is doing is it's doing a lateral heterogeneity in all the basement cells first, for 1 iteration, and then it's going to change for each step no more than 0.01 grams per cc, and then it's going to turn over and do a geometry inversion. So if I go to the data colors here, and let's just do 0.175. So now the depth of basement has both some lateral heterogeneities as well as some relief. Let's just double check and see how well we did with the inversion. So that was the initial model, or the data, and then the depth of basement is on the same color scale. And that's what each one of these look like. So it did a decently good job. And I can look at the residual as well. So the residual is on a slightly different color scale, but the depth of basement is on the same. And just as, since I'm here, I'll also look briefly at the low pass filtered and the geometry. So there's the residual and then the geometry. So you can see it didn't quite do it, but it gave me the overall broad spectrum, which is why I wasn't too worried about it. Now, the nice part is if I go again, and let's say I really try to ramp this up, and I do something, I go, whoa, wait a minute, I took way too much of a step. I can always undo and go back again to where I was. Looks like I undid too much, but that's okay. So let's go to, and one more. Great. And of course, with VPmg, you can go through and do more geometry, more basement style. So the basement is the lateral heterogeneities and just the basement. We could do some homogeneous inversion. So right now we've assumed that the top of the model is 0 grams per cc, but we could actually optimize that as well and do a whole bunch of stuff. So at this point, I'm actually looking mostly at the model and the residual and doesn't make sense geologically. As soon as I get something that I feel like is pretty good and makes sense geologically, I can then put it in, instead of showing it the model, what I can do is I can create a grid from all these units. And this grid contains the thickness. So this is the thickness of the overburden. So basically this is this would be the same as, the depth to basement. So from the very top all the way to my basement unit, regardless of whether or not I have 2 units or 100 units, this would give me my depth to basement. I also have my basement top. And from that top, just like I did with the DEM, I can just create a surface and give me my basement top. And now this surface can be exported to be able to put into another software if you're doing more hard geologic modeling, or you could bring in other information, of course. I just started from just the data. So if I had drill holes or something like that, I could start to do constraints and start to really try to get a good initial model before I start with the inversion. I believe with that, I tried to keep it short, and I'm at about 12 minutes. So if there's any questions, Carla?
Yeah, thanks, Chris. And thank you to everyone who joined us today. A quick reminder that some of these tools haven't been released yet, but they will be available in the next version. And for any of you who are in the lecture, if you have any questions, feel free to type them into the Q&A or raise your hand. If you have any questions in the future, also, please don't hesitate to email us at support@mayorgeoscience.com. Don't miss out on next month's virtual lecture when I will be showing data visualization and knowledge sharing tips in Geoscience Analyst for your viewer. And thank you everyone so much for coming. Oh, we do have a question. Sorry.
Can I demonstrate how I might add constraints from other geologic information? So unfortunately, I can't demonstrate it because I don't actually have geologic constraints from this in general. What happened is you would get points, and we could create surfaces on those points. And not only could we create the surface that we started with, but then we could tell VPmg to not change that surface. So in the case of the geometry part, we could actually hold the geometry steady at some points. The other thing we can do with VPmg is we could actually invert just part of the data. So we could select a section of data and then hold everything else at the end. There's another question. Do you have plans to include inversion using gravity gradients in the future release. What I didn't show, because I briefly went over, is for depth to basement actually, and the geometry as well. The data can be gravity magnetic or gravity gradiometry. So you just put in your Bell or Falcon and you could go from there. And then what type of data did I use to create the basement? Well, in this case, I just had an initial guess, but if you had some really fast things like Euler deconvolution, you could actually bring those points in from Euler deconvolution and not really worry too much how accurate they are, but you could at least get an initial surface from the points. So you could drape a surface on those points and then use that as the initial surface.
All right, so we'll just wait a little bit to see if anyone else has another question. All right, so it doesn't seem like it. So thank you everyone so much for coming, and we'll see you next month.